On the evening of January 27, 1967, 3 astronauts sat inside their Apollo spacecraft on Pad 34 at Cape Kennedy, Florida. Gus Grissom, Ed White, and Roger Chaffee were running a routine launch rehearsal for what was supposed to be the first crewed Apollo mission. The cabin was sealed and pressurized to 16.7 pounds per square inch of pure oxygen, more than 5 times the partial pressure of oxygen in normal air at sea level. The interior was lined with roughly 34 square feet of Velcro, nylon netting, and foam pads. At 6:31 in the evening, a spark ignited somewhere near the floor. In that hyper-oxygenated environment, materials that would barely smolder in normal air burned twice as fast. Within seconds, the cabin became an inferno. The hatch opened inward, which meant it was physically impossible to open against the rising internal pressure. About 15 seconds after the first cry of fire, the pressure split the hull. The fire melted the astronauts' suit oxygen hoses, exposing them to the toxic cabin atmosphere. Autopsies later found non-uniform carboxyhemoglobin distribution in their blood, the forensic signature of death within seconds of massive carbon monoxide inhalation. All 3 men were gone before anyone on the outside could reach them. The Apollo 1 fire nearly killed the entire moon program, and it should have. Because here is the detail that still haunts people at NASA to this day. The crew had flagged concerns about flammable materials in the cabin just weeks earlier. A safety walkthrough to verify the issues had been fixed was scheduled for January 29th, 2 days after the fire. Then NASA did something that defined the rest of the program. They stopped. For 18 months, they tore the spacecraft apart and rebuilt it. The inward opening hatch was replaced with an outward opening, quick-release design that could be opened in seconds. Flammable materials were stripped from the cabin. On the launch pad, they switched from pure oxygen to a safer nitrogen-oxygen mix. And every one of those changes carried through every Apollo mission that followed. To understand why NASA was cutting so many corners in the first place, you have to understand the pressure they were under. In October 1957, the Soviet Union launched Sputnik, a beach ball-sized satellite that became the first artificial object to orbit Earth. America's response, the Vanguard rocket, exploded on the pad that December. The press called it Kaputnik. Then in April 1961, Yuri Gagarin became the first human in space aboard Vostok 1. 5 days later, the Bay of Pigs invasion failed. 2 humiliations for the Kennedy administration in the same month. So on May 25, 1961, President Kennedy stood before Congress and committed the nation to landing a man on the moon before the decade was out. A Gallup poll that same month showed 58% of Americans were against the idea. This was not a noble science project. It was Cold War face-saving with a hard deadline, a skeptical public, and the Vietnam War burning through the budget. Every shortcut that killed the Apollo 1 crew came from that pressure. After the fire and the redesign, NASA needed to make up for lost time. And this is where one of the most underappreciated decisions in space history comes in. George Mueller, NASA's Associate Administrator for Manned Spaceflight, came from the Air Force Minuteman missile program. The traditional approach, championed by Wernher von Braun, called for testing each stage of the Saturn V rocket separately across roughly 20 launches, with at least 10 uncrewed test flights before putting anyone on top. Mueller threw that plan out. His directive was called all-up testing. The very first Saturn V flight would launch all 3 stages live, with a real spacecraft on top. Either it worked or it didn't. Apollo 4, launched on November 9, 1967, was that bet paying off. The 5 F1 engines at the base of the Saturn V ignited and produced 7.5 million pounds of thrust. The launch shook Walter Cronkite's CBS broadcast booth 3 miles away so hard that reporters held the ceiling tiles in place with their hands. Every stage separated perfectly. The spacecraft re-entered Earth's atmosphere at lunar return speed. It was a total success. Apollo 5 followed in January 1968, testing the lunar module in orbit for the first time. Engineers remotely fired its descent engine and its ascent engine, proving the ungainly spider-shaped lander actually worked in the vacuum of space. Then Apollo 6 in April 1968 nearly ruined everything. Violent pogo oscillations shook the rocket during ascent, ripping panels off the spacecraft adapter. 2 second-stage engines shut down early. The third stage refused to restart in orbit. On paper, it was a failure, but the data it produced was invaluable. Engineers traced every problem, fixed every flaw, and declared the Saturn V ready. Muller's gamble had compressed a decade of testing into roughly 5 months. Apollo 7, commanded by Wally Schirra in October 1968, was the first crewed Apollo flight and the first real test of the redesigned spacecraft that had been grounded since the fire. 11 days in Earth orbit, 8 near-perfect engine firings. The command and service module worked, the path to the moon was open, and then NASA made a decision that still seems reckless, even by 1960s standards. Apollo 8 was originally supposed to test the lunar module in Earth orbit, but the lunar module wasn't ready, and intelligence suggested the Soviets might send a crew around the moon. So NASA changed the plan. Frank Borman, Jim Lovell, and Bill Anders would fly the command module all the way to lunar orbit on only the third crewed Saturn V flight ever. Borman privately rated his crew's chances at 50-50. On Christmas Eve 1968, those 3 men became the first human beings to orbit the moon. They read from the book of Genesis during a live broadcast that reached an estimated 1 billion viewers worldwide, roughly 1 in 4 people alive at the time. Bill Anders snapped the Earthrise photograph, showing our planet rising over the gray lunar horizon. Wilderness photographer Galen Rowell later called it the most influential environmental photograph ever taken. A telegram arrived after splashdown that said simply, "Thank you Apollo 8, you saved 1968." Apollo 9 in March 1969 proved the full spacecraft worked. For the first time, astronauts undocked the lunar module, flew it independently, and redocked in Earth orbit. Everything performed exactly as designed. Apollo 10 in May went further. Tom Stafford and Gene Cernan flew the lunar module down to just 9 miles above the moon, scouting the landing site for Apollo 11. NASA had deliberately underfueled the lander so the crew wouldn't be tempted to go for it. Every piece of the puzzle was now in place. On July 20th, 1969, Neil Armstrong and Buzz Aldrin began their powered descent to the Sea of Tranquility in the lunar module Eagle while Michael Collins orbited above. And almost immediately things went sideways. The onboard computer started flashing 1202 and 1201 program alarms, 5 of them during the descent. The computer was being overwhelmed because the rendezvous radar, left on as an abort backup, was flooding it with spurious data. In the back room at Mission Control in Houston, a 24-year-old computer specialist named Jack Garman had a handwritten cheat sheet taped under the plexiglass on his desk. 2 weeks before launch, a simulation supervisor had thrown this exact alarm at the team during a training run, and guidance officer Steve Bales had called an abort. They got chewed out. Flight director Gene Kranz told Garmin to write down every possible alarm code and what it meant. When the real 1202 hit during the actual landing, Garmin knew instantly that as long as the alarm wasn't continuous, the computer would recover on its own. The call went up to Bales, then to the crew. "We're go on that alarm." Meanwhile, a navigation error had put Eagle about 4 miles long of the planned landing zone. The computer was steering them straight toward a boulder field surrounding West Crater. Armstrong took semi-manual control at about 400 feet and flew the lander sideways, searching for clear ground. When the descent engine finally cut off, Mission Control's gauges showed roughly 17 seconds of fuel remaining, though post-flight analysis later estimated about 45 seconds. Either way, it was close. "Houston, Tranquility Base here. The Eagle has landed." Charlie Duke's response from Mission Control captured the moment perfectly. "You've got a bunch of guys about to turn blue down here." An estimated 530 million people watched the first moonwalk on television. Armstrong and Aldrin spent about 2.5 hours on the surface, collecting samples and deploying experiments, including a laser retroreflector that scientists are still pinging today. Apollo 12, launched on November 14, 1969, nearly ended before it got off the ground. Pete Conrad, Dick Gordon, and Alan Bean lifted off through rain clouds, and 36 seconds after launch, a triggered lightning bolt struck the Saturn V stack. 16 seconds later, a second bolt hit. Every warning light on the instrument panel lit up. The attitude indicator started spinning. Telemetry went completely garbled. Down in Mission Control, a 24-year-old flight controller named John Aaron recognized the pattern. A year earlier, he had traced a similar data scramble during a simulation back to an obscure piece of equipment called the signal conditioning equipment. He keyed his microphone and said 4 words that saved the mission. Try SCE to aux. Pete Conrad had no idea what that meant. Neither did most of Mission Control. But Alan Bean recognized the switch, reached down, and flipped it. Telemetry came flooding back. That call earned Aaron the highest compliment in the NASA building, steely-eyed missile man. The landing itself was a masterclass in precision. Conrad set the lunar module Intrepid down roughly 535 feet from the Surveyor 3 probe, which had been sitting on the moon for 2.5 years. They walked over, removed parts from the old probe, and brought them home. Apollo 11 had proven humans could reach the moon. Apollo 12 proved they could land exactly where they wanted. If you're enjoying this, consider subscribing. It really helps the channel, and you won't miss videos like this one. Apollo 13 launched on April 11, 1970. What most people don't know is that the bomb that nearly killed Jim Lovell, Jack Swigert, and Fred Hayes was built on the ground, long before launch. Oxygen tank number 2 had originally been installed in Apollo 10's service module, was removed for modifications, and at some point was dropped about 2 inches. During a pre-launch test, technicians couldn't drain the tank normally, so they ran the internal heater overnight to boil off the liquid oxygen. The thermostat was rated for 28 volts, but ground power had been upgraded to 65. The thermostat contacts welded shut, the temperature spiked to roughly 1,000 degrees inside the tank, and the Teflon insulation on the fan wiring was destroyed. Nobody caught it because the temperature gauge only read to 80 degrees. 55 hours into the mission, Jack Swigert flipped the switch for a routine fan stir inside that tank. The damaged wire arced, ignited the insulation in pure oxygen, and the tank ruptured. The explosion blew a panel off the service module and began venting the second oxygen tank into space. The lunar module Aquarius became a lifeboat. It was designed to support 2 men for 2 days. Now it had to keep 3 men alive for 4. The immediate threat was carbon dioxide. The lunar module scrubber canisters were round. The command modules were square. They didn't fit. Back in Houston, Ed Smiley, head of NASA's Crew Systems Division, designed what the crew would call the mailbox. It was a square command module canister wrapped in a plastic bag, sealed with cardboard cut from the cover of the flight plan, with a spacesuit hose running through it, and the whole thing held together with gray duct tape. Mission Control read the assembly instructions up to the crew step by step. Within 30 minutes of building it, carbon dioxide levels started dropping. Meanwhile, Ken Mattingly, who had been bumped from the crew days before launch due to measles exposure, worked out the power-up sequence for the dead, frozen command module from the simulators in Houston. The crew splashed down safely on April 17th. It remains the greatest rescue operation in the history of spaceflight. Apollo 14, commanded by Alan Shepard in early 1971, was the comeback. Shepard had been the first American in space 10 years earlier, but an inner ear condition had grounded him for years until surgery fixed it. At 47, he became the oldest astronaut to walk on the moon, the only Mercury 7 astronaut to do so, and the only one to smuggle a golf club onto another world. He landed at Fra Mauro, the original target for Apollo 13, and NASA could finally breathe again. Apollo 15 in the summer of 1971 changed the entire program. It was the first J mission, designed for extended stays and serious science. David Scott and Jim Irwin landed at the stunning Hadley Apennine region, right on the rim of a massive channel called Hadley Rill, with the lunar Apennine Mountains rising 15,000 feet around them. They were the first crew to drive the lunar roving vehicle, and during their second moonwalk at Spur Crater, they found the Genesis rock, a 269-gram chunk of anorthosite that had crystallized from the moon's ancient magma ocean roughly 4 billion years ago. It was one of the most significant geological discoveries of the entire program, Scott also performed Galileo's hammer and feather experiment on live television, dropping a geology hammer and a falcon feather simultaneously and watching them hit the dust at exactly the same time. Apollo 16, commanded by John Young in April 1972, targeted the Descartes Highlands, a region scientists were convinced was shaped by ancient volcanism. They were wrong. The rocks weren't volcanic at all, just rubble fused together by meteorite impacts. Apollo 16 overthrown a major theory in real time, which is exactly why you send human geologists to another world instead of just reading about it. Apollo 17, launched on December 7, 1972, was the grand finale. It was the only night launch of a Saturn V rocket, lighting up the Florida coastline like daylight. Commander Gene Cernan and geologist Harrison Jack Schmitt, the only trained scientist to walk on the moon, landed in the Taurus-Littrow Valley for 3 days of exploration. At Shorty Crater, Schmitt spotted something nobody expected: bright orange soil. It turned out to be tiny spheres of volcanic glass, roughly 3.64 billion years old, frozen droplets from an ancient lava fountain, one of the strongest pieces of evidence for the moon's fiery geological past. Over 3 moonwalks totaling 22 hours, Cernan and Schmitt drove 22 miles across the lunar surface and collected 110 kilograms of samples, the largest haul of any Apollo mission. They even had to fix the rover after Cernan accidentally broke off a fender extension, fabricating a replacement from taped-together map sheets. On December 14, 1972, Gene Cernan climbed the ladder of the lunar module for the last time. Before he stepped inside, he said, "As we leave the moon at Taurus-Littrow, we leave as we came and, God willing, as we shall return, with peace and hope for all mankind." No human has set foot on the lunar surface since that day. And it wasn't supposed to end there. Apollo 18, 19, and 20 were planned. The landing sites were picked, the crews were in training, the Saturn V rockets were built and ready. Then the budget cuts came. Apollo 20 was canceled on January 4, 1970. Its rocket reassigned to launch the Skylab space station. Apollo 18 and 19 were canceled that September. The net savings from scrapping 2 moon missions was $42 million. Today, those rockets sit in museums. The Saturn V at Johnson Space Center in Houston is made entirely of flight-certified stages that were built to carry astronauts to the moon. The lunar module built for Apollo 18 sits in the Cradle of Aviation Museum on Long Island, where Grumman originally built it by hand. 3 Saturn V rockets, 3 lunar landers, 2 command modules, all built to fly. None of them ever did. In April 2026, NASA's Artemis II mission flew 4 astronauts around the moon for the first time since Apollo. They did not land, 53 years and counting since the last boot print in the lunar dust. 12 people walked on another world using less computing power than a pocket calculator, backed by 400,000 people on the ground who somehow made the impossible routine. Every mission built on the one before it. And every one of them, from the fire on Pad 34 to the last footprint at Taurus-Littrow, is proof of what happens when people decide that something has to be done and then refuse to stop until it is. What do you think the next chapter of lunar exploration will look like? Let me know in the comments.